Okay, the stream is likely switched over. People from the chat box, let me know if y'all can hear us when you can hear us. Okay, thank you. Welcome, everyone. Appreciate you joining us soon after the New Year's. The agenda is pretty short, so we'll see. I'm not sure how long the meeting will last today. But I wanted to keep the momentum moving, so I'm glad y'all made it. As always, we're going to get started with client updates. How about we start with Lodestar today?
Yeah, sure. Can you guys hear me well?
Yes.
Cool. So it was a little bit slow in some areas, but our state transition helpers are pretty much complete at this point on the implementation side, and we're just shy of 50% tested. We started building out the POW chain deposit contract listener side, so kind of how the start functionality of the actual whole thing will work out, collecting the deposits up to the chain start event, and that we have it kind of stubbed, and we're working our way through that to kind of get the whole thing started, so we can start generating the Genesis and at slot 0 and all that. Outside of the beacon chain, we've finished up our fixed size number library. It's pretty much complete. There's a few little tweaks we need to fix in the test cases, but it works. So we are going to be importing uints and ints into the beacon chain probably this end of this week or early next week. So we can be as close to the spec as we can, especially with types. And outside of that, we've started getting a couple contributors, which is nice outside of ChainSafe. So we have 3 people right now contributing pretty actively, everywhere from issues to pull requests. So that's pretty much what's been going on so far. And we've been working on our BLS a little bit more.
Great. I'm curious about the monitoring of the proof of work chain. Are you using Web3.js with some underlying client or what?
We have it going right now using ethers. We just prefer to use ethers in most of our stuff because they also have a TypeScript. Richard created a TypeScript version of it recently, and basically just monitoring it and collecting the deposits that way. If that's what you're kind of asking.
Yeah, cool.
Yeah, our next thing is to switch it over to a job so that we can have the ETH1 deposit event being looked at all the time, and then we can collect them in the background, and then instead of having to reparse the smart contract, we can just take it from what's happening behind the scenes.
Great, thank you. How about Nimbus?
Hi. So in Nimbus, we kept in sync with the latest spec changes. We also progressed, and I think we are a one-to-one with the spec regarding state. So we now have a state simulator, and we can transition between states with, for the simulation, 1 epoch per second. And the next step is for trust rule. We also have network simulation working. So it works real time with machine-to-machine communication. And the next step for that is persistence. Also, the test generator repo that we had at Status has been upstreamed to Eth2.0 tests. So the shuffling test will be updated there, and all the new tests will be added there. Also, we also focused on giving the community some way to reproduce and set up the NIM Ethereum 2.0 ecosystem on their machine. So there is now a Vagrant container available and a tutorial. I will post the link in the chat box. And this should allow you to set up easily everything you need to run NIM and Ethereum in your Linux or Windows machine. And lastly, we also have the development updates in a blog post form, and that was done at the end of December, so it's like from 5 days ago. And you can have the detail on everything we were doing in there. And the link is also in the chat box.
Great, thank you. How about Xiaowei with the PyVM side?
Oh, hi. So the past 2 and 3 weeks, we are keep trying to sync with the specs and rework our code-based architecture. And also we added more custom type hinting in our Python code base. And once it fully finished, we can update the spec as well and make the spec more readable. And next week, we are planning to give some input for the tree hashing test vectors. The PySSE functions are almost finished. And also we'll add more documentation in the Python code base. Now that's our updates.
Great, thank you. How about Pegasus?
Hi. Just finding that mute button. So we open sourced Artemis over this winter break time, and we started getting some open source contributors. I want to say we had two, and we also have opened up a Gitter channel for communicating with those open source contributors. We kind of completed our VRC interface for Artemis. We are starting work on gRPC, our BLS verification, and hash tree root. So we opened a minor PR that was closed and merged 351. That was like a minor modification to the validator relay contract. And just yesterday, we opened an issue regarding the validator records. In this last, I think it was like probably an update like 20 days ago, where the validator balances were moved from the validator record. I'm not sure what they call it in Python, but I assume object, right, into the beacon state. So that's where we are. Ben's still producing his what's new in Eth2. If you don't read that, you should. I think that's pretty much it for us for updates.
Great, thank you. How about Prismatic?
Yeah, hey, this is Terrence from Prismatic. So I guess it's been pretty slow due to the holidays, but we have accomplished a lot over the last 3 weeks. We deprecated the old code with the old spec, so we did some code cleanup, and we aligned the spec. We have implemented about 90% of the block operations, block processing, and the epoch processing functions. We also finished implementing the function to process the validator deposits. And on the libraries end, we finished implementation of SSZ and the tree hashing algorithm. And similar to Nimbus, we're working on a state simulator as well. So we're using a simulated backend to test per block, block processing, like a YAML format. And yeah, that's it.
Awesome, thank you. How about Sigma Prime, Lighthouse?
Hey, we've been a little bit similar, that it's been slow over the holidays, but we've still been progressing. We've been stripping out a lot of the old spec. Adrian's been progressing on rusted P2P. Got a PR waiting for tree hashing, which we're looking forward to seeing those test vectors that were mentioned earlier. So we've been stubbing out some of the new spec stuff just to try and avoid duplicating work. So we've been moving more towards sync and RPC, and also kind of thinking about the architectural considerations around code being shared between components like validator clients and so forth. That's about it from us.
Great, thank you. Harmony, I know in Russia they have their New Year, it's the main holiday, so they're not here today. I know they've been continuing actively working. Did I miss any other? Oh, Parody, Frederick.
Hey, yeah, we've been sort of the opposite of everyone else. We've taken the opportunity of relaxing holidays to do some work. Or I should say way ahead. So he's been trying to update our previous implementation to the latest version of the spec. I think we've run into a couple of snags, like the change from Blake 2 makes it a little bit more complicated for us. We have to introduce some abstractions that we weren't planning on doing at this stage. The decision to not switch SSZ to little endian basically makes it so that we have our existing kind of codec is the same except for endianness. So same thing there, we'd have to introduce a level of abstraction we weren't really planning on. Overall, though, I think it's kind of going okay, and you know, we'll see where it goes, and if we can keep going on substrates, then you know it's still pretty awesome, and we get everything else for free. But if we can't, then I think in the new year we'll once we have like the final version of phase 0 fully known in January, then we'll take a more critical evaluation on whether or not we'll continue on substrate or start a new project.
Cool. Thank you. Did I miss any other clients? Great. Next up is research updates. Justin, you want to start?
Sure. So I guess, you know, we're still finding bugs all the time in the spec and fixing them, which is great. Another kind of thing that we're doing is trying to simplify the spec where possible. And what I'm, you know, probably most happy about is simplification of the validator status code logic. So we used to have this somewhat complicated state machine with various validator status codes, and there were all sorts of edge cases when you do the transitions. That's mostly gone almost completely. So it's been replaced with timestamps in the validator records. And we still have some what we call status flags now. So it's, yeah, there's only 2 flags, so it's quite simple. One of the things that we're looking to move towards is this idea of a locally computable shuffling. So what we have right now with the Fisher-Yates logic, basically, in order to calculate the shuffling of a specific validator or a specific committee, you basically have to it scales linearly with the size of the validator pool, and we wanted to scale better. And once we have this locally computable shuffling, then it means that we can be light client friendly without all sorts of light client specific infrastructure. So this means that we can also simplify the beacon state. So specifically, we had this, in my opinion, rather ugly shard committees add slots data structure. We also had stuff like the persistent committee reassignments. And this was, you know, again, infrastructure for light clients. And now that we have this news, now that we have more information about the validators with these timestamps, and we're looking to have this locally computable shuffling, we can remove that. We're also looking to potentially remove the validator registry delta chain. and rely on the the double batch Merkle accumulator that was added recently. So that's another simplification, which is nice. I guess I've also tried to push for kind of a clean separation between phase 0 and phase 2 and phase 1. So a few bits and pieces of logic and constants have been removed. And I guess other than that, I've tried to push for cleanups of the code base. Sorry, not the code base, of the spec. But yeah, I guess that will take quite some time because we're trying to do it in such a way that is not one big kind of pull the plaster in one go, but make lots of small pull requests. So I expect that to go on until the end of January, but I think overall we're on schedule for having a very reasonable and nice spec for the end of January.
Excellent.
I had a question about the phase 0 and phase 1 thing. I was wondering a little bit what the thinking is there, because I saw that some phase 1 things are being added in placeholders and stuff like this. Like from a spec implementation point of view, that slightly complicates things. And I think that if we're going to do phase 1, I don't know, 6 months, a year after phase 0, I think we will have learned many lessons there and we'll want to change it further. So as a general approach, wouldn't it be better to focus on upgradability and making sure that the upgradability of the protocol is solid and then leave the phase 1 stuff out?
So I would tend to agree. So I guess what we've been taking so far is an approach where we're stubbing the data structures in terms of the messages that are passed around and gossiped, and the structure of the beacon state. And the idea there was that once we do the upgrade, we don't have to fiddle with that and add special cases. And basically, beyond these placeholders, we try and avoid as much as possible any logic for other than for phase 0. I mean, I would be in favor of completely removing also the placeholders, but I guess other people in the research team have other opinions. I don't know what you think, Danny.
I go back and forth a little bit. It's the balance between trying to figure out what the future holds and trying to reduce the amount of spaghetti code that will be in these clients. I mean, every fork, you don't really get to get rid of logic and get rid of old code as you upgrade a blockchain, and so it's a little bit different than creating most systems. So if we know something's going to be there, I'd like for it to be embedded in the data structure, but maybe we can make a more informed decision in February. It's like if before we launch the phase 0 beacon chain, we have what looks like the beginnings of a robust phase 1 spec, then I'd say put the data structures in there and put the components of the data structures in there. But if it seems like a major unknown, then just pull them out.
Yeah, because generally when you're like in protocols in general, when you upgrade stuff, it's always easy to add things. It's much harder to remove them. And that might be something to consider for SSD as well, whether we want to include some safe mechanism for adding things.
Agreed. I think we could, especially on SSE, consider what upgrading that looks like. There's at least some consideration on what upgrading the beacon chain looks like in terms of that built-in versioning around messages and data structures. But I don't know. As I said, my opinion on it kind of goes back and forth. I think it's reasonable to have it in there if we have a firm phase one when we're launching phase zero. But we can take that maybe in a month or so.
Yeah, sounds good.
Any other research updates? Pegasus team? Not to put you on the spot, I just know you'll have some researchers.
Nobody's going to jump in. I'll speak on behalf of the team. So main focus is on Stanford Blockchain Conference, where we're presenting a paper on BLS signature aggregation at scale. I know that there's some interest amongst those present in seeing details of that. So I think the team's busy just doing the tests and the write up of that. So hopefully in a couple of weeks we'll have something we can share ahead of the conference. I think that's pretty much it for today, unless Nicolas Guy, you want to add anything?
No, basically, yeah, we're planning on running a large-scale experiment next week, so we should have some preliminary results by the end of next week or in 2 weeks. So far, we only ran large-scale experiment on the simulator, Wittgenstein. Now we're planning to do on Amazon EC2 instances. So the development is in pretty good shape now, and now the experimentation phase is the next one.
Great, thank you.
Nicola, I have a question.
Yeah.
When you say you are planning to run larger scale, can you give us some numbers or setup of what you're planning to run on Amazon?
Yeah, so we're gonna try to run on like 4,000, 5,000 nodes, because after it becomes a bit more expensive. So at least that we plan for up to 5,000 nodes, if I remember correctly.
Okay, thanks.
Cool. Any other research updates before we move on to the P2P update?
Yeah, just short updates here from BSC.
Great.
We have open source the simulator. So it's already on GitHub and it's available online. And so we have a first version of the simulator that is ready and running. We already tried it on the supercomputer and it scales well. And so now we are planning to tackle two questions. The first problem that we would like to study with the simulator will be the point that was discussed during the previous conf call about how fast or how slow different charts will evolve in the case of having a low number of validators. So what happens if we turn up when we switch to sharding, we have a lower number of validators than expected, then how this will impact the evolution of different charts and the old imbalance between charts and this kind of thing. And the second problem that I would like to study is related to a point that was raised by Alexi, and it was about the relationship between consumed gas in the blocks and the anchor rate. So there is already an article, a paper that was written on this. I thought it's quite it's about a couple of years old. So I think it would be interesting to study this one with more updated data, and in the case of sharding. So these are the two points that we plan to study with the simulator. That would be all.
Thank you. On the original, the first point at which you planning on studying, the you said the evolution of the shards in a, I guess, a low validator count environment. Evolution in what respect? generally, in a low validator count environment, you have kind of an even distribution across the shards. So what exactly are you planning on looking at there?
So if I understood correctly last time, when you have a certain number of, you have a limited number of validators, what happens is that some shards would have kind of, they would take longer time to be able to validate or to do this cross communication between the shard and the beacon chain, and therefore the shard blocks will take longer time to be kind of committed into the beacon chain, and that is because validators will be working in other charts, and so some charts will be working slowly. Is this correct understanding, or did I miss something?
Right. So there a few nuances there. There are always two shufflings of validators. So as a validator, I always have two roles, and one of which is a long-term role on a shard, and I'm always committed to one shard at a time. And if there's n shards, there's validator count over n number of validators on each shard, and the shards, regardless of the amount of validators on that shard, until you reach very, very low numbers, can build at the normal clip of one block per slot. There is another shuffling. They're called shard committees. They might change to crosslink committees because that's what they do. They crosslink, and which is a separate set of validators from the persistent committees, which are building the shards. The time with which the crosslinks occur can become longer in times of lower validators. So although the shard chains are still building at the same clip, they're only getting a finalized reference into the beacon chain on some slower. So instead of maybe once per epoch, it might be once every 2 epochs, or might be once every 4 epochs. And so again, you're degrading the performance of being cross-linked in, which could degrade the performance on cross-shard communication. And it might do some interesting things to the fork choice rule of the shard chains. I'm not entirely certain what they're, but the fork choice of the rule of the shard chain always starts from the last cross-linked reference in the beacon chain. And so you could have these longer stretches without a cross-link, so you're more dependent on the fork choice in the shard chain than when you're quickly cross-linking in. So there might be some interesting stuff there around the stability of the fork choice rule, but these shards still able to build at the same speed. They're not actually slowed down in their building. Does that make sense?
Yeah, correct. Correct. I was talking about the cross links.
Okay.
And how they link to the beacon chain. Yeah. So I agree with you. There are some interesting things to look into that.
Cool. Excited to see results. Thank you. Raul from libp2p is here. I would like to give an update. Raul.
Hi everybody. Happy 2019 to everybody. I wanted to say thanks for all the useful and actionable feedback we've received on the roadmap. We, the core team of libp2p, will be meeting in Porto in 2 weeks' time, more or less, to, amongst other things, finalize the roadmap discussions. And of course, you're invited to attend if you're around. Just get in touch with me. This is open, it's public to everybody. We finished our goal setting for Q1 2019 for the libp2p project, and particularly for the Go and JS implementations. The Rust implementation is lagging a bit behind. We hope we can gain speed on that in the next weeks. And of course, supporting Ethereum continues to be a priority and a top level goal for us. And other key topics that we're addressing are multi-stream 2.0 to reduce the latency of establishing connections and leverage certain functionalities of new transports that we're introducing, like Quick, which allows for zero round trip negotiation. We're also going to be working on a plan which we're calling DHT 2.0, which basically introduces a number of new functionalities such as overlay DHTs, privacy, secrecy, and other features. We're also focusing on interoperability testing and visualization tools. And also we're starting to actually start discussing packet switching with a bit more depth than we've done in the past. I'll post a link to our OKR sheets in the chat box shortly. Then on the Pi libp2p front, we are waiting on the grant resolution to move the project into the libp2p organization. I think that's going to pick up some speed as well in January. Also, we've got some news on the front of Go package management. This has been a bit of a pain point for a lot of downstream adopters, the usage of GX as a package manager, and we are going to be taking a spike this quarter to evaluate adopting Go mod in general, and even perhaps replacing GX if the hooks that Go mod exposes allow us to bring in some features like content addressability and so on, some guarantees that GX gives us. And yeah, I wanted to provide a follow-up as well on the conversations around that we had in the last call that I was present in regarding the native bindings for the libp2p daemon. We have been working on a plan with Pegasus as well, who are the contributors of this patch, to support compiling native libraries with bridges to other languages. So one of the use cases that we're targeting is embedding the libp2p daemon in environments such as iOS. I know that Status in our Eth2.0 workshops in Prague, somebody from Status said that this would be desirable for them. I can't remember exactly whom. So I'm hoping that by calling it out in this call, that person will raise their hand, because I think we'll be able to support this very shortly. And I really hats off to the Pegasus guys, because they've been very proactive about getting this patch merged, and we've defined a plan with different phases to make sure that this is done in an orderly fashion, because it does imply a change in architecture in the daemon. And I can post a link to the comment where that plan is summarized. That's all for me. Open for questions if you've got any.
Sorry, I missed the exact point that was called out by somebody from Status.
Yeah, same.
Yeah. So somebody from Status suggested that having a deployable form of libp2p for iOS environments, and particularly the libp2p daemon, would be useful as a first, experiment of running libp2p in iOS applications. Basically, the idea they came up with was, well, now that we have a daemon and the daemon is exposing local endpoints over IPC, and apparently iOS supports IPC and Unix domain sockets, then creating a native implementation, an implementation of the libp2p daemon that compiles down into a native library that can then be deployed onto an iOS environment would be useful as a first spike here.
I think maybe the concern raised was that we have to use it as a library. We can't run it as a daemon, a separate process on iOS.
Right, exactly. So the idea here was to find a form such that an iOS app can start the daemon and interact with it over Unix domain sockets inside the operating system itself.
I think you're going to have a pretty hard time actually with Unix sockets on iOS. I wouldn't recommend it.
I personally don't have any past experience in that, but I'm open to suggestions there. We are definitely we are introducing a TCP transport, a local host transport as well, to interact with the daemon and to send control messages to the daemon back and forth.
Yeah. I think this is a good strategy just because of the difficulty of implementation of libp2p in each of the different languages that may need to use it. Just having a way to kind of like marshal requests into a standard daemon is a good strategy.
Yeah, so I can't really say more about the particular requirement on status. I think it was somebody from status. Have you guys been working or thinking about adopting libp2p in your iOS apps?
It's on our list of things to do. We're not looking at it right now.
Got it. We can take it offline as well and discuss in another forum.
I would suspect, however, that the daemon for us is a short-term solution. Generally, we would prefer to natively implement protocols. So we appreciate a focus on making language neutral specifications and protocols that can be re-implemented at a networking level as well.
Yeah, we are planning to get better at that as well in 2019 at essentially becoming a spec first project that makes it easier for other downstream implementers to engage and to build implementations. So one of our focus for the next years is going to be mobile adoption as well, because this is important for a number of use cases, offline use cases that we want to address with libp2p. I do expect at some point we will be seeking a Swift native implementation of libp2p for the time being. Well, Swift and of course the Java one is already underway. For the time being, I think the daemon itself. So the problem with the current model of deployment of the daemon is that it's basically a binary, right? I don't think you can run a binary in iOS just as is. So by compiling it down to a native library, this would enable you to interact with the daemon, to start the daemon as a library inside your iOS app and interact with it over, it could be IPC or it could be TCP endpoints, local endpoints. So that would be kind of like the first step on that path.
Yeah, but over time, generally implementing a well-defined spec is usually easier than bringing in an entire development environment that is not native to the platform.
Yeah, totally agree with that. That is one of our focus for the near future.
Cool, thanks. Yeah, we'll get back to you on getting iOS, but it might take a while. We're currently focused more on spec updates and need to do stuff in general.
Of course, yeah, got it.
Thank you. Any other questions for Raul before we move on? Great. Felix, I'm very glad you're here. I was wondering if you could give us a quick update on the state of Discovery v5 and maybe give us some insight into what needs to happen before the spec moves into a production-ready standpoint, and what maybe we can do to help.
Oh yeah. So basically, the thing in the new year is that the effort on the Discovery v5 is split into two different efforts. So one is getting the whole topic thing worked out, and then the other one is the actual wire protocol. So I put Frank on the wire protocol, so he's basically taking care of that now. I don't know if you've met Frank at DEF CON, but he's also been working on the new test suite for the rest of DevP2P. So, but now that the test suite is done, he's moved on to actually taking care of the wire protocol tasks, like just basically getting a preliminary spec in place. And then when it comes to the topics, yeah, so over Christmas, like not much has happened, but yeah, I'm still at the point where basically I'm trying out the simulations that, what's his name? These someone from Brainboard did.
Yannick.
Yeah, exactly, Yannick. So Yannick did some simulations with OMNet, and I've been trying to actually get this to run on my laptop. So that's approximately where I am right now. But I don't have any sort of. I've tried to kind of keep my queue clear on the Geth side, so I have more time in the beginning of the year now to actually really look into the Discovery version 5, because so far it's always happened that basically I've just been swamped with like Geth tasks, and right now I don't have any like big pending Geth tasks left. So yeah, it should actually be possible for me to update you pretty regularly on these calls. By the way, like how often are these calls? Is there like a fixed schedule for these? Are they like every 2 weeks?
We do, yeah, we do it every 2 weeks. I think it's been 3 since the last one because of the holidays.
Oh yeah.
But every 2 weeks.
Okay. Yeah, I'll try to have,
I'll get you directly, like I'll make sure an invite's going directly to you.
No, I am actually getting invites. I've been
cool.
getting invites like for the last last 8 incarnations of this meeting. It's just I've never been able to make it.
Yeah, well, we're glad to have you. And again, like keep us. We're congregated in the sharding getter. So if there's something specific that you want some feedback on, or input, or help implementation, or anything like that, please let us know, because this is really a top priority is figuring out the discovery protocol, because one of the components that is still not quite locked down at this point.
Yeah. All right.
Cool.
So I guess I will have more to say like in the next meeting.
Perfect. Thank you.
Awesome.
Any questions for Felix before we move on? Okay. Any other general just updates? We didn't have a lot on the schedule today. Before we move on to any spec questions. Okay. Next thing is just spec discussion. If there's questions, comments, concerns on things going on in the spec.
One question that I have is regarding running beacon nodes. So the incentives for running that. There's an active issue regarding that and the spec. And there was some concerns that Bruno brought up in the previous call. I'm just pulling up the spec right now, in which we would have to design the validator clients in a particular way in order to preserve privacy, because otherwise wouldn't be able to get privacy. Let me just search for that.
So there's, just to answer the beginning of that question, there's many incentives to run a beacon node. One would be I'm a validator and I want to have my own direct connection to the network to get the state of the world and to sign messages and to seek profit. Another might be that I have some sort of service in which I have the state of the world and I provide information about the state of the world to others, either for free altruistically or even in some sort of paid model if I needed some more incentive to run it. Another reason you might run one of these nodes is because you are running any sort of application. A block explorer, Etherscan would run a node or many nodes. I mean, it's similar into why do I run a current proof of work node? One small set of people doing that is for mining, and the rest are either altruistic actors in the network or people who have applications or whatever. And so again, it's pretty much anyone that has a reason to be running the protocol directly would be running one of these nodes. And again, the beacon node, which is really just an implementation of the protocol, it's like the beacon chain is the core system level stuff that I need to sync the application chains or the shard chains. And so that's just kind of the core piece of infrastructure, and then I sync whatever chains are relevant to my needs, whether I'm a validator or a block explorer or any sort of application that might need to sync one of these chains. Does that answer part of the question? What's the rest of the question?
Yeah, I think that answers part of the question. I'm still looking for that issue.
Oh, let me see if I can pull it up real quick. I know the issue. I have not commented on the issue in a while, but I know I have not closed it. Yeah, it's issue 157. There you go. Rigo asked a question in the chat. Is there a reward for running a beacon node? There is no. Similar to running a... So again, a beacon node, I don't know what the correct terminology is, that is just an Eth2.0 node. There is no direct incentive for running one of these. There's no direct reward for running one of these, but if you do want to become a validator, post up some amount of ether and to begin to validate the network alongside your node, then there is a reward.
There seems to be more discussion about this on Reddit. So I think I'll just read through this, and then in the next call or just during the next 2 weeks, I'll be asking more about this.
Okay. Thank you.
I wanted to ask again about issue 386, what I had touched on earlier, the validator balances being moved into the validator record. And I guess PR 317, which was the updates that made the changes to that. Kind of like doing some preliminary reading, the moving my understanding is the moving of the validator balance into the beacon state is for hashing optimization.
Yes.
Is that language specific to Python?
No. So we used to have two states, the active state and the crystallized state. The active state was small and had to get rehashed frequently. The crystallized state was very large and would get rehashed every epoch. We had the separation because we were using a flat hash and really had no ability to cache the components of the state that had not changed, or cache hashing. When we moved to the SSZ tree hash, we now have isolated the various components, the arrays, and the objects from each other into this hash tree. And so when you say update just the balance of one validator and need to rehash the data structure, most of the components of the tree remain stable, and you have to do a relatively low number of hashes to update. This was generally perceived as good and fine when we were using Blake as the hash, because Blake is faster than SHA-3 or CAC-256. When we switched to CAC-256, we decided that most of the validator record is not updated frequently, but the balances every epoch most of the balances, if not maybe all the balances, are updated via the rewards and penalties. And so by moving the balances out, we've isolated what needs to be the large component of what needs to be rehashed into a smaller data structure. And so we're able to benefit from caching the validator record, the hashes of the validator records a lot more, and isolate the amount of hashing that has to be done. And this was in an effort to reduce the loss in hash time, or the increase in hash time, when we move to CAC 256 from Blake. Does that make sense?
Yeah, totally makes sense. Okay, so maybe I'm proposing, and I may open an issue for this, maybe a name change for the validator balances, just because kind of like because we moved it from validator registry, there's kind of like I don't know, I think like sort of a naming collision in validator registry and validator balances, maybe like epoch validator balances or something might be more appropriate.
Why epoch? They are the balances of each validator. So there's a 1-to-1 relation between your indice, your validator indice, and your balance in this validator balance array. It's just we moved it out of the validator data structure so that we can reduce the amount of hashing that needs to be done.
Okay, got it.
But open to name changes. I don't know if epoch does what we need to do. Explains what we need to explain though.
Got it. Yeah.
Cool.
Thank you.
And there's a few locations in the spec where there's, note this is why this is happening. And that this might be a prime target for a little note.
It's all covered in what's new in ETH2. Try and keep up. Danny, I've got one. So there doesn't seem to be a lot of documentation about what the expected behavior of a block proposer is supposed to be, a beacon chain block proposer. I guess it's possible to infer it from the spec because we've got the kind of validity side is down. But as an exercise, I went through what happens, how are block proposers supposed to deal with deposit receipts from the main chain, and it took me quite a few hours to reverse engineer it to try and find out exactly what the proposer is supposed to be doing, and I'm still not sure I've got it right, and it doesn't seem to be documented anywhere. So I've done that in the sharding Gitter, what my conclusions are, and I'd be glad if somebody can check and make sure that correct me where I'm wrong. But is there a plan to be a document or a place somewhere where we just spell out?
Yeah, we've kind of talked about that in the past, and that you're right. The entire what a validator do is implicit on what is valid in the beacon chain, which is good in that you can separate these two things. But I think that an accompanying document of what, quote, an honest validator does, just spelled out very explicitly, is I think would be a valuable addition to the spec repo. And maybe we can open up an issue for that. And January is probably beginning to be a good time to put that in there. Maybe it was a little early before, just in that spec moving a lot. You'd have to be moving 2 documents at once. But I 100% agree, spelling it out makes sense.
Cool. I'll be happy to work on that. It was totally non-obvious what the proposer behavior was supposed to be from what's written in the spec. So it would be great to
right, especially with respect to that proof of work component. Yeah, agreed. Okay.
Yeah, but if anyone's got time to look at Gitter about an hour ago, then please check my working.
Yeah, I've been. I'm kind of on. I'm on vacation this week, not right now apparently. But I plan on getting to the string of Gitter comments at some point today. Thank you. More spec stuff?
Yeah, so I had a question on the validator client architecture. So in the spec, you have to validate that the block state root is equal to triage the state. So does that mean as a validator client, you would actually have to compute the state transition on the client side and then attach it to the block? Then only you propagate the block, you send the block to the beacon node.
No, I would say that in that relation that the node is calculating that state root and providing it to the validator. The providing essentially a block proposal to sign. similar to in a proof of work miner, the node provides a proposal that the proof of work miner is supposed to try to hash. So the heavy lifting, I think, should happen in the node. The main information that needs to pass along to the validator is enough information so that the validator can decide if this is a safe or dangerous message to sign. I think strategies for the validator to assess the validity of the information, I think that's more of a trust relationship, and the validator maybe should be asking multiple nodes or something there. But I don't think that essentially the signing entity should be doing much of the heavy lifting. Obviously, there's a lot of design work there. I would say you wouldn't want to be passing the entire state to the validator. I think you're passing more of these block proposals to sign. Does that make sense?
Yeah. All right. Thanks.
Someone else was jumping in right around that question.
Oh, hey, Danny, this is Raul from Prismatic. Yeah, Nishant was asked the same thing, but with respect to syncing shard chains, I think we don't want, we were talking before a lot of spec changes about having the beacon node sync and then send the information to the validator client. However, like we think that this makes it a lot harder to decouple the two, in the sense that, you can't, we want to be able to swap the underlying beacon node, but if you're really, really dependent on one beacon node for everything you do, and in particular, you don't really have that much data that you store locally as a validator client, and you're also not peer-to or P2P, then that becomes a little bit harder to come up with some sort of architecture where you can easily swap the underneath beacon node. Have your thoughts evolved on?
I think the opposite. I think that I think that makes it much more difficult. In that the validator should be responsible for the data that it's signed and the data that it's signing. Thanks, Jacek. And can request that information from any node, a node that it runs, a set of nodes that it runs, a node that it runs, and some node that it doesn't run. It can get that information from any entity, make local decisions on what it's signed, store any information that it needs to about the decisions that it signed so it can make good informed decisions in the future, and then it can pass these signatures along to something that's connected directly to the P2P network to broadcast. Once you start putting P2P requirements on a validator, you've now increased the scope of this entity massively. And you've also now directly connected a validator with signing keys to the internet and to a P2P network full of potentially malicious actors. And so I think even from just a security standpoint, you've now moved the validator out of a place of isolation to an incredibly risky place. So again, back to the swapping, if the validator only asks questions about the state of the world and the state of things that it might sign, then whomever it's asking questions to, it's very, very easily swapped as long as there's a common interface to ask these questions. Once I've put in P2P requirements, processing requirements, all sorts of stuff, I've started to just build a node inside of the validator when there's already robust node implementations. Why am I essentially repeating all of this logic? One of the big things on the data requirements on the validator is that the validator, any information that it's computing proof of custody bits on and essentially has to store data over a long period of time, it actually has to pull that data down. But a node is already syncing data from the world. It's much easier to just ask for that than for the validator to also have to sync data from the world. And again, you cannot sync shard data without a constant connection to the beacon chain. And so if a validator were to have to directly sync shards, then the validator would have to constantly be passing information between the shards it's syncing and the beacon chain that it's connected to, and becomes all of a sudden becomes like this core piece of the infrastructure to sync a shard. Beyond that, a node needs to be able to sync shards without a validator existing, because there are many use cases for a node. One is to be a validator. Others are to run applications, to be block explorers, to be a hobbyist, all sorts of things. People that aren't validators, and so a node has to be able to sync shards. Like if a node can't sync shards, it's not very useful. And if a validator has to sync shards too, now we have to sync shards. We have two different entities that have to be able to sync shards, which again sounds like repeat work and kind of like a blurring of concerns. That's my philosophy and view on it.
Got it. Cool. We'll keep that in mind. Thank you.
Yeah. Questions, comments, concerns?
I just have a couple comments on stuff that was brought up. One point was about the endianness of simple serialized. I think Frederick brought that point, and it sounded like a decision was made. I don't think a decision has been finalized, and if there are considerations we should take into account, and I think it sounded like there was, I would encourage you to comment on the open pull request, Frederick. The other comment I have is on the honest behavior, and I think it's actually very simple. So I'd like to try and just spell it out in like a couple sentences. So basically, step 0 is just apply the validity rules on the various blocks that you've received, and then you got this this block tree. So you have various forks. Then you apply the fork choice rule, so you get a single kind of canonical blockchain. And now your duty as an honest proposer is to build on top of the tip of this canonical chain. And there's basically only two things you need to do from the point of view of deposit roots, which I think was the point that was brought up. Number one, you need to cast a vote for a deposit root from the Ethereum 1.0 deposit contract. And the rule there, and I'm actually not sure it's actually spelled out in the spec, is that you want to vote for the latest one, which is contained in a block which has height 0 mod some power of 2. So for example, every 1024 blocks on the Ethereum 1.0 chain, you're going to have a corresponding deposit root for whatever you consider the Ethereum canonical Ethereum 1.0 chain, and then you just vote for that. And then as soon as you have the required threshold of validators who have voted for that specific root, then that becomes, right now it's called process deposit root, but it will soon be called latest deposit. So you have this latest deposit root. And then the second thing you need to do is that you need to include deposit receipts from Ethereum 1.0 into Ethereum 2.0. You need to include them in order. You need to include up to 16 of them. So that's specified in the max deposits constant, which is equal to 16. And you need to include them up to basically the latest deposit root that has been voted upon. And I think that's it.
And I think we're currently missing a validity condition on ordering of those deposits in the spec currently, but it will be added. Yes, that is it. There are complexities there, so I think it is worth spelling it out in a document. And there is going to be an increasing, there are a few other things. I mean, the proposals, but the attestations, when and the timing of when you're expected to do things with respect to a slot. Like you're expected to attest to the head of the slot actually halfway through a slot rather than at the beginning. This is just kind of knowledge floating around but not really stated anywhere. And again, there's going to be an increasing number of requirements on a validator as we move through phase 1 and phase 2. But thank you for the explanation, Justin. Anything else? Open discussion.
I would just point out that the Nimbus team will be congregating in Brussels just after FOSDEM. So basically on the dates February, 2nd to roughly 8th, we'll be in Brussels in case anybody wants to meet up. We'll probably have a little hackerspace somewhere where we'll be sitting and hacking on Nimbus together.
Awesome.
We had mentioned something about a workshop in Q1. Are there any additional details on that or consensus on where/when it will be?
We have generally decided, at least from the EF side of when we're going to be actually doing an event, we've decided to work our asses off in Q1 and to congregate in Q2. And we don't have locations thrown out. We're Sydney during EdCon, potentially Barcelona, but again, more in the April-May range. And that other...
Formally, though,
yeah.
There seems to be a lot of people at ETH Denver, right?
I will be there, yes.
Ditto.
Yeah, if we want to get together day before just to hack and chat, we can definitely do that.
Yeah, I think a lot of from our team will be there as well.
Cool. Okay. Anything else before we close the meeting? Great. Okay. Well, thank you everyone for coming. I know it was really close to the New Year's and the holidays, but I'm excited to keep the momentum going. As always, don't hesitate to reach out in the Getter. We'll schedule one of these, I think, in 2 weeks. I don't think we have any conflicts. I'm generally out the next few days, so I'll be a little bit slower in responding to things, but I'll be back in full force on Monday. Thank you, everyone. Talk to you all soon.
Thanks, Danny.
Happy
Bye,
New Year.
Thanks.
Bye, thanks.
Bye.
Thank you.
Bye.
Bye.
Bye-bye. Thank you, Danny.